So now let's move on to chords. So a chord, this might be a term that you're less familiar with. A chord is a line that connects two points on the circumference. So this can literally be any 2 points, and chords can therefore look like they can look very different to each other. So for example, this is a chord because it connects these 2 points. This is a chord because it connects these 2 points, and this is a chord because it connects these 2 points. The only example that would not be a chord is if it passes through the centre of the circle, because if it passes through the centre of the circle, this isn't a chord, this is actually the diameter. So this isn't an example of a chord, but everything else is. So the key feature of a chord is a perpendicular bisector of a chord will pass through the centre of the circle. So you can see this if it's in diagrams, where if we draw a perpendicular bisector through this chord, it will pass through the midpoint and it will go through the centre. Remember that it will split it into two equal parts, and this is perpendicular. If we do it for this chord, it will pass through the centre, and it will split it into two equal parts, remember, and it will be perpendicular. And for this chord, it's the exact same. It will pass through the centre, splitting the line into two equal parts, the chord into two equal parts, and it will be perpendicular. Just recall that it has to be a perpendicular bisector. It can't just be a perpendicular line, as that won't pass through the centre, and it has to be the bisector of the line, obviously. Additionally, if you know two chords in the circle, the point of intersections of both their perpendicular bisectors will be the centre of the circle, and we'll talk about this more in the triangles and circles properties video. So there's quite a wide variety of questions they can ask you on this topic. They're only going to use the skills learnt from this chapter and there in these videos, but they will also apply the straight line graphs chapter, the skills learnt in there as well. But my best advice to tackle the wide variety of questions is just to do the E and EP questions in exercise 6E, 6F, which we'll move on to in the next video, the mixed exercise in chapter 6, and the review exercise, to master how these questions will look and how to apply these techniques. I'll go for a few examples now that I think are quite representative of what you could be asked. So this is quite a typical question on chords and perpendicular bisectors. So for part A, as I said before, I always find it helpful to draw a diagram in order to help with questions like this. So we know that point A is -4, 9, and point B is 0, 5. So we'll do point A somewhere up here and point B somewhere down here, where A is -4, 9, and B is 0, 5. And we have the chord that connects these 2 points, and we'll say the centre is somewhere here. And we have the perpendicular bisector of this chord, which is going to look something like this, where it's going to be perpendicular, it's going to split this line into two, and this is called L1. So we need to find an equation for L1. Now the way we can do this is because we can find the gradient of AB, because we have 2 points on it. So we can say that the gradient of AB, this little AB down here, just signifies that we're talking about the gradient of AB when we're talking about two different gradients. The gradient of AB is going to be 5 minus 9 over 0 minus -4, which if we put this into a calculator or just figure it out, is equal to -1. So therefore we can find the gradient of L1, once again, I hope you're not getting confused by these little subscripts here. The L1 here just means now that I'm talking about the gradient of L1 compared to AB. Again, if you don't want to use these, you don't have to, but I'm just going to do it here in order to show my working. So the gradient of L1, as they're perpendicular, the gradient of L1 is going to be the negative reciprocal of -1, so the gradient of L1 is going to be 1. So that's the gradient of L1, which we need to know. But we need to know a point on L1, and we can do this by finding the midpoint of A and B, because we talked about this, that the midpoint is going to be a point on L1, and the midpoint of A and B is going to be the midpoint of the x coordinate and the midpoint of the y coordinate, of the two y coordinates and the two x coordinates. So the midpoint of -4 and 0 is -2, and the midpoint of 9 and 5 is 7. I just did that in my head quickly, but you could use the formula. So now we have a point on L1 and the gradient of L1. So therefore we can use the formula y minus y1 is equal to mx minus x1. It's going to be y minus y1, which is going to be y minus 7, because we use this up here, is equal to m, which is just 1, x minus -2, which is going to be plus 2. We can just simplify this to y minus 7 is equal to x plus 2, and then we can move everything onto one side to do x minus y plus 9 is equal to 0. And this is the equation of the line, because we don't need to simplify it because it's already integers, so we don't need to times it by anything. So for part B, we need to find the value of k, and we know that the centre of the circle is -4. Okay, so aka for this question, we need to find out the y coordinate for the centre of the circle. So remember that the perpendicular bisector of a chord will pass through the centre. So therefore that we know that the line L1 is going to pass through the centre, aka the point -4k. So therefore we can find the point k, as it is just going to lie on L1 when x is equal to -4. So we can use this equation and just say that -4 minus y plus 9, which is going to be equal to -y plus 5, if we simplify, is equal to 0, and therefore we can just say that y is equal to 5. So therefore we know the centre is now -4, 5, so we know that k is equal to 5. We're able to figure that out because of the feature of perpendicular bisector of a chord, which we talked about before. With a perpendicular bisector of a chord will pass through the centre of the circle. So therefore we know when x is -4, where it is in the centre for this chord, that will give us the y value of the centre of the circle. So for part C, we now know the centre of the circle, which is equal to -4, 5. And if you recall the centre, the equation of a circle, sorry, x minus a squared plus y minus b squared is equal to r squared. We know a and b now because we know the centre of the circle. We just need to know r. Well, we can figure out r because we know the centre of the circle and we know 2 points actually on the circumference, and therefore the radius of the circle will be either of the distance between these 2 points, the centre and the circumference. Recall the distance formula: d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, and all of that is square rooted. So we just need to do that for the centre and either of the 2 points to find the length of the radius. I'm just going to use b because it's got 0 in it, so that'll make it easier. So d is equal to the square root of -4 minus 0 squared plus 5 minus 5 squared. And if you put that into a calculator, we'll just figure it out quickly. It is equal to 4. So therefore the equation of the circle is x minus -4, which will be plus 4 squared, plus y minus 5 squared is equal to the radius squared, which we figured out the radius is 4, so 4 squared is 16. And this is the equation of the circle.